wherever we are, whatever we're doing. The information that empowers and connects us comes back to our global data centers. Built for a secure, sustainable, and digital world, they make the invisible visible and anything possible. And that's the great thing. Together, we do great things.
Chennai, known as the gateway to South India, is one of the major IT and data center hubs in the country. The Adani Group now plans to build world-class data center infrastructure in the city of Chennai. The Adani Chennai 1 data center is the biggest hyperscale data center in Chennai with a 32 megawatt IT load. It is strategically located in Sipcot IT Park with direct connectivity to the National Highway and other major IT hubs in Chennai. The data center is being built to meet global standards with 7 layers of security, best-in-class power usage effectiveness, redundant fiber connectivity and green energy. The Adani Chennai 1 shall be equipped to provide one-stop solution for all telecom and IT infrastructure needs of hyperscale customers, including low-latency network connectivity, high-performance computing, and other value-added services. Through this data center, the Adani Group aspires to contribute to the local economy while continuing a work towards nation building at large and being steadfast on our philosophy of growth with goodness.
Founded in Germany over 100 years ago by Anton Piller, the company has a long history in the manufacturing of exceptionally high-quality electrical machines and power quality equipment. Today, as part of the multidisciplined global British engineering group Langley Holdings plc, Piller is a world leader and innovator in a number of power protection technologies, specializing in UPS systems for mission-critical applications and frequency converters for aircraft ground power, amongst other uses. Piller UPS systems are found in applications where continuous high-quality power is paramount, such as computer data centers, financial institutions, broadcasting, telecommunication networks, airports, healthcare facilities, and continuous process production sites. Nothing protects quite like Piller.
It's amazing what humans have accomplished. Cars that think, machines that learn, healthcare that predicts. The progress of tomorrow has yet to be imagined, but it will rely on data. It will rely on Vertiv. Vertiv ensures data gets where it needs to be uninterrupted. Critical power is always running. Servers perform at optimal temperatures. Infrastructures grow safely and responsibly. Applications run without glitches, and life leaps forward again. Getting there takes vision and agility. Our leading experts think beyond infrastructure, connecting the dots to create integrated, intelligent ecosystems, to create a future that takes innovation to the next level. And when business needs shift, we work closely with our customers every step of the way. Together, we ensure they are ready before they ever need to be. Vertiv provides continuity in our digital world, so we remain unbound, liberated, free to create the next big thing. Vertiv, architects of continuity.
Great things change things. Wherever we are, whatever we're doing. The information that empowers and connects us comes back to our global data centers. Built for a secure, sustainable, and digital world, they make the invisible visible and anything possible. And that's a great thing. Together, we do great things.
Dr. Shivraj, can you please take over from here? Dr. Shivraj, can you please take over from here?
So good afternoon, everyone. We had fantastic start of Data Center Summit 2021 conference on green and resilient data centers. We welcome all of you to day 2 of our Data Center Summit. First of all, I would like to invite Mr. Syed Mohammad Berry to deliver welcome remarks. Mr. Berry founded the Berry's Group in 1981 and has been leading the green building movement in the country, delivering excellence consistently and triple E, that is entrepreneurship, environment, and education, sum up the spirit and foundation of Berry's Group. Berry's Group is presently developing
I'm sorry, I think there's some technical glitch from Dr. Shivraj end. May I kindly request Mr. Syed Mohammad Berry to deliver the welcome remarks, sir. Thank you, sir.
Okay. A very good afternoon to everyone. After the resounding success of yesterday's inaugural session, it's a great privilege and honor to invite all of you on today's day 2 session. Yesterday, we had a wonderful day, right from the inaugural session, wherein our chairman of IGBC, Mr. V. Suresh, and the CEO of NTT, Mr. Sharad Sanghi, and Mr. Senior Vice President Mahesh Trivedi of NTT, their presentation and all that value engineering they're bringing has given us a great deal of satisfaction, and we are looking forward for the day 2 and day 3 session. In addition to the inaugural session, we also got the opportunity to release the user guide implementation ECBC 2017 for the data center, joint initiative of IGBC and LBNL USA. After that, we had a wonderful 3 session, on the green initiative of the data center, and then joint initiative of IGBC and LBNL on the user guide implementation, and finally the NetApp data center in Bangalore as a case study, where they have brought in a lot of value engineering, including free air cooling and things like that. Today, we have again, Mr. Shivraj and the team has worked out a beautiful itinerary, bringing in the industry veterans and experienced stalwarts, and they're going to put their viewpoints to ensure that eventually we need to reach we need to make every data center in India green and resilient. And on that score, I once again welcome each and every one of you. In this, first and foremost, I would like to invite Mr. Subhashish Majumdar, the Managing Director of World Energy Company. He will, after my welcome speech, is going to talk. Then the first session is about emerging sustainable solution for data center. So for this, Mr. Rolf Brink, the founder CEO of Asperitas, he is already with us, and Mr. Shailendra Bais, Director Pillar Power India Private Limited, he is also going to join, and this is very, very important session. The second session is about the state-of-the-art innovation in data center. See, it is of my opinion, data center cannot exist in isolation. Data center, where all the stakeholders has to come into a, on the common platform, right from the operator, and the developer, the architects and the consultants, MEP consultants mainly, the vendors, the subcontractors, all need to come in a single platform. That is where we can really take, a data center to the next level. If you work on isolation, then it will become very, very difficult task. So right from, selection of the property, that itself, according to me, take about 20% of the overall, rating requirement. The right site, if you select by virtue of its location, accessibility, power availability, and all other things, that helps a great deal. Then comes the design. In the design, from the architecture point, there are 2 factors. One is how to optimize, and mainly optimize a white space. It is not how much we build, it is what we build and how much maximum we can create as a white space. And the facade treatment. All that matters. And MEP consultant, of course, because data center is all about cooling and heating. So MEP clients, consultants are playing a very, very important role. So in that, again, we have a fantastic session. That is the second session of today, which is moderated by Mr. John Booth, the Managing Director of Carbon 3 IT Limited UK, wherein again the veterans like Mr. Mahesh Trivedi, Senior Vice President of the entity, Mr. Sudhanshu Dutt, Director of ACOM, and Mr. Prasad, Controllers Data Center Vice President, Mr. Srijit, Vice President Operation of STT, and Srirang Deshpande, Country Manager for World India. And the third and the last session of today's is about excellence in data center through technological advancement. You see, the only way we can reach to the next level is about the technology and innovation. Technology and innovation, primarily how we can reduce the energy consumption. The energy guzzler, what we are doing today, that cannot sustain, that cannot be a sustainable model at all. So all the industry leaders, they need to work. They need to put their mind together and come out with the innovation, by virtue of technology and latest equipment and stuff like that, whereby we have to have a clear roadmap. Say in 10 years down the line where we should reach, 5 years down the line where we should reach, and by 3 years down, how much power we can reduce. That is one important aspect. And then third one again, we have Mr. Murli Sinal, Senior Group Vice President of Reliance, and they're also in a big way in India. And Mr. Thompson from Armstrong Fluid Technology from Canada. And the one other important event of today is, Mr. Michael Beatty is going to talk about water smart data center. This is absolutely important. This is really going to help a great deal for the data center development in India. And of course, this will be moderated by our own, Dr. Shiv Dhaka. And with this, once again, I invite all of you to, invite you for this second day session. And, I wish that, I wish all the, I wish the second day session will help us a great deal in understanding and taking the data center to the next level. Good luck and God bless. Thank you.
Thank you, sir, for your welcome remarks. It always inspires, it always gives a lot more energy to work towards sustainable in data centers. So thank you once again for your time, and we look forward to your suggestions and strong recommendations for having data centers more and more sustainable. Now I would like to invite Mr. Subhasis Majumdar, Managing Director, Vertiv India Energy Private Limited. He has more than 20 years of rich experience in different portfolios, and he serves the desire to have some remarks for the industry, how it is growing, and what would be the best learning considering innovations in data centers. Over to you, Mr. Majumdar.
Thank you, Mr. Shivraj, and thank you, Mr. Berry, and thank you, CII and IGBC for conducting this summit and giving us a platform to share ideas and thoughts. A very good afternoon to all the participants and delegates too. Very insightful discussions yesterday, and I was listening to some of them, and a lot of experience coming through. So really great day. If you look at the data center space, I think that it's a very exciting space right now. A lot of activity around that, and that is reflected through the number of announcements that we are seeing both from existing players and new entrants. We believe that this industry is probably going to grow at around 25% CAGR over the next few years, which means several hundred megawatt of installations coming in the next few years. So while it bodes very well for us, and while we build those data centers, what will be important is that energy efficiency will be the cornerstone for sustainable progress. And what we'll have to ensure is that energy efficiency nullifies the impact of the energy consumption of these new upcoming VCs. I think CII, IGBC is doing a wonderful job working tirelessly with industry bodies, with manufacturers like us and the data center player to work on policy documentation around that. Really congratulate the organizations for implementing the ECVC in data centers. We at Vertiv have been actively participating in some of these things, so we want to continue with that, and I definitely believe that this will help in improving the PUE levels of the industry. We are also proud to share that one of our data centers that is an IGBC green certified, platinum certified for one of the premier private sector banks, and it was one of the first to achieve that distinction in India. So we are in this. So if you look at the data center industry over the past decade, I think there's a lot of work, transformation that has happened, and with average PUEs probably coming down by around 30-35%. And we as manufacturers and data providers, partners, we are going to continue to invest in technology to continue this journey and make sure the PU levels come down further. We are seeing a lot of these emerging technologies gaining a lot of traction. like the liquid immersion cooling, the adiabatic and evaporative free cooling is becoming convenient to use with the increased air temperature. We are also seeing waterless solutions gaining traction with one of the users deciding to implement that above 200 kilowatt. So all this bodes very well for the space. I think interesting times, exciting times. And then the next few years, we'll see a lot of new technologies emerging and getting adopted. While we do a lot in the technology space, and I think this is my last point before I hand it over, I think what we also need to ensure is that we invest in talent and build up a skill set which can take this industry forward with this technology changes that is happening. So I think that's also the piece that we should have in our mind. So with that, I think we have a lot of eminent speakers lined up and a lot of interesting discussions. I'll not take much more time. Thank you once again, CII and IGBC for conducting this. Thank you. Stay safe and stay healthy.
So thank you very much, Mr. Majumdar, and we are really thankful to you for supporting IGBC activities. Very recently, when we had the first data center for one of the banks, you had this project and it was IGBC Platinum certified. So thank you for all the support, and we look forward to your guidance and support in future as well.
Thank you, and look forward to more interactions.
Now we would like to invite Mr. Rolf. We have a great speaker on a very interesting topic. He's a founder and CEO of Asperitas. He is having more than 2 decades of rich experience in IT. IT is the main domain for data centers. IT is the main reason behind we are putting so much effort in that. His background in product development for cloud architecture and data center infrastructure, combined with a passion for clean tech innovations like liquid cooling, are the foundation of development of immersed computing within Asperitas. In addition to Asperitas, Rolf Brink is leading industry initiatives through Open Compute as part lead of Immersion, one of the most interactive communities in OCP, by authoring and simulating standards, white papers, and enabling harmonization across liquid cooling technologies. Rolf Brink is leading the global adoption. So we are really fortunate. It's a real pleasure for us to have you today, and we are sure liquid cooling, liquid computing will have many more scope in India, and all the data centers which are operating at very high PV today could be 1.6, 1.7. They can immediately think about immersion computing, immersion cooling, or liquid technologies to bring down their PV significantly lower. Over to you, Mr. Brink. We are very happy to have you today.
Well, thank you very much for that very kind introduction. I genuinely appreciate that. So let me get started. Can you just confirm that you're hearing and seeing everything correctly?
Yes, it is much
Okay,
clear,
thank you.
and your voice is also loud.
Thank you very much. Okay, so my name is Rolf Brink. I'm indeed the founder and CEO of Asperitas. And Asperitas is a leading immersion cooling provider, which is providing data centers around the world with high quality immersion solutions. Since 2015, we've developed groundbreaking technologies which are driven by the idea that data centers should play a fundamental role in a global energy transition. The Asperitas mission is driven by the awareness that data centers around the world can and must become energy neutral by becoming an integral part of a much larger grid of energy solutions. We have won numerous awards and have received international acclaim from reputable platforms like SDIA and World Economic Forum for our consistent focus on sustainability and innovation. And today, Asperitas is globally recognized as an industry leader due to our strong role within the Open Compute project, a global platform which is currently driving the efficiency and innovation of our industry. Asperitas technology is a high quality and very efficient cooling technology on the market due to a unique immersed computing concept, which is driven by natural convection circulation, but more on that later. We are collaboration driven throughout the industry, and with respect to India, we've been working closely with Boston India to supply and support our customers with end-to-end high efficiency and high availability compute platforms. But before I lose myself with Asperitas, allow me to provide you with some context related to our joint industry and why sustainability is key. A lot has been happening, and with COVID-19 in 2020 and still going on, there has been an accelerated and unprecedented move towards cloud-based platforms. Data centers are now more critical than ever, and we are also seeing the start of the 5G rollout, which is accompanied by increased data generation and additional load on infrastructures. HPC platforms are on the rise as well, often driven by AI and machine learning workloads. Servers requiring 2 kilowatts per rack unit are no longer an exception. And on parallel, the chip densities have been increasing dramatically, where only a few years ago we were working with 40 watts processors. Now the lowest spec is around 135 watts, while average chips have been nearing 200 watts. And this is only for the mainstream enterprise platforms. And this is posing challenges for traditional means of cooling, while the growth triggers a strong focus on sustainability worldwide. Which means that we just explored some of the main challenges which the data center industry is facing. The increase in chip power is not something temporary. There is already talks about raising these levels to 400 watts and eventually even 800 and 1,000 watts. This is not something which the industry can support in most current facilities. And at the same time, the industry is trying to increase efficiency and reduce cost. And this is at conflict with the higher densities, as these are getting more and more difficult to condition and keep protected. The technologies which the industry has developed on for so long are still innovating and to accommodate this. But most innovations and optimizations are in the margins of what is possible. So the urgency for efficiency is furthermore pressured by the drive for sustainability. Our planet is focused on climate change, and steps must be radical to ensure that our children will have a safe environment to live in. And the data center industry is responsible for a major part of this energy footprint, which is why it is a logical and impactful target for sustainability measures. Last but not least, there is a new driver in the industry, and it's called 5G. The global rollout results in an exponential increase in data processing, and due to latency and infrastructure cost, the processing will take place in the edge. There have been many talks in the industry which relate to edge, but allow me to be short. Edge is where data is being created, where connectivity is always moving, and where the information demand is. Edge is the people. Where there are people, there is data processing, and where there's data processing, there is a need for data centers. And this results in a global urbanization of data centers with all challenges associated with such environments. That is also good news in 2020, and that's backed by significant steps for sustainability in the industry, and very clear goals have become a fundamental part of corporate strategies worldwide. This is also emphasized with the big announcements last year by the hyperscale companies. All main hyperscalers are committed now to become carbon negative by 2030, some by 2040. Microsoft has taken this one step further by committing to the full erasure of their historical carbon footprint by 2050. These plans are welcomed by two of the largest economies in the world, the European Union and China. Europe has set the ambitious goal to become climate neutral as a continent by 2050, followed by China with the pledge to become carbon neutral in 2060. And this is exactly the kind of leadership that the world needs right now. But it's not very easy being green, and especially India is dealing with major energy challenges while dealing with an energy demand which is projected to grow by more than any other nation over the next 2 decades. The Indian data center industry is part of this growing demand with rising temperatures around the globe. India is breaking records each year again, and this is increasing the power envelopes for cooling for each and every facility in the country. Even those which can benefit from lower temperatures are being challenged by water consumption associated with adiabatic cooling, which utilizes evaporation of water. This is putting additional strain on one of the world's scarce resources and leading to regulation initiatives around the world. And the sad reality is that data centers, not only in India, but globally, often require more power for cooling than for the actual IT equipment. As already mentioned, edge developments are accelerated by the global 5G rollout, which is coming with an exponential increase of data processing around distributed microdata centers. And these facilities will have to be deployed in both remote and urban environments. And this provides a whole new range of challenges ranging from available power connectivity to cost of footprint and noise nuisance, as well as the potential for effective heat reuse. highly efficient, climate-independent platforms with minimized overhead are required to meet these challenges globally. So how can we address all these challenges? Well, the good news is that we've seen these challenges coming at us for years now. Basically, everything comes down to a fundamental shift to liquid cooling. And everybody in the industry is now familiar with at least the concept of liquid cooling, but only a handful are actually using, deploying, or scaling with it. The most well-known form of liquid cooling now relates to rear door coolers. These are water-cooled heat exchangers which act as air handlers at the rear door of the rack, and these are efficient and eliminate the need for facility-wide air transport. These are already the new norm for air cooling and are integrated in the new rack standards, especially within OCP. Cold plate is mostly applied in HPC and supercomputing environments, while now becoming an occasional add-on for mainstream systems. Full cold plate racks are often equipped with rear door coolers because cold plates only cool the most essential and hottest chips in a rack. Immersion is also known from HPC applications and is now breaking through to become mainstream strategy for HPC and high-density platforms. The biggest value of immersion lies in the holistic, all-encompassing cooling approach. Since the IT equipment is fully immersed, 100% of the converted energy is captured in a dielectric liquid. And this full cooling ability is therefore the most important contributor to addressing efficiency and sustainability goals. And this becomes clear when looking at the more explicit effects of liquid cooling strategies. Rear door heat exchangers are very efficient due to the usage of water as the main coolant circulation throughout the facility. It is, after all, easier to exchange heat with water than it is with air. However, because they function in the same way as air handlers, low temperature cooling will still be required. Cold plate implementations are allowing at least part of the infrastructure to work with elevated temperatures, which in turn allow more efficient and compressorless cooling measures. Cold plate also allows a minor reduction of IT power due to the capture of heat within the chassis, although usually limited to the main heat sources. Because of this, cold plate is often combined with rear door coolers to allow full capture of all heat at rack level. This still requires low temperature cooling, while other parts can operate with elevated temperatures. Immersion is about literally immersing the full IT systems, and this results in a holistic type of cooling which captures 100% of the IT energy and can operate with elevated temperatures for the full platform. This also means that immersion often enables a year-round operation with free cooling strategies. A small note should be added, though, that everything that I'm explaining about these technologies is dependent on the IT platform, which needs to support the same elevated temperatures and heat production. Some HPC and supercomputing operators would therefore prefer to stick with chilled water circuits if that enables higher clock speeds, for example. While mainstream enterprise applications often have a greater focus on efficiency and high temperature operation. So there's a lot that needs to happen in the industry, and some of that may not be fully scaled yet. So what does it take to change the global industry? Let me start with the following question. Who led the digital transformation of your company? So take your pick, A, B, or C. So if somebody came up to you 1.5 years ago and would tell you that it would be possible to do all office work remotely in half a year time, what would your response have been? I know what mine would have been like. It all comes down to necessity. COVID-19 forced an immediate change around the world in record time. Businesses were all facing an existential crisis, but luckily the tools existed to deal with this. These tools have been developed, tested, and prepared over the past years, but nobody had seen COVID-19 coming. The paradigm shift for data centers is something which we have all had in plain sight. The industry has been calling for change during the past 5 years. The foundation for this change is driven by technology, relating to Moore's law and sustainability, relating to efficiency and growth. Chip power is exceeding what is possible to maintain with air. It is pure scientific, and we have seen this tipping point coming. It is the fundamental resistance against change which puts the industry in a position from which it now tries to and protect the status quo. And platforms like ASHRAE, institutes like Uptime, global providers like Schneider Electric and Vertiv, and many, many others have flooded the industry with warnings about the persistence of air cooling and how that will prevent the industry from dealing with the new realities. This is nothing like COVID-19. The surprise element does not exist. We know when and where it will happen because there is plenty of statistical and scientific data underlining the most important message of today. This is no longer a future projection because this is today. Why is it then that there are still so many facilities operators and large cloud providers who are ignoring this reality? It all relates to a classical friend or foe comparison, the resistance against change and the perceived risk of the unknown. But it's incredibly important to realize that change always comes with opportunity, and the real challenge is to determine whether you can benefit from this opportunity or not. Now, data center operators are experts in the unavailability and uptime, and the last thing they will do is take risks with conflicting information and incredible marketing pitches, and any technology which is allowed into a facility is subjected to a good amount of scrutiny, and any doubts raised in the industry will not only affect a single brand, but the entire technology domain. Think of this example, think of this argument like this. Tesla you had a few instances of electrochemical failure in the cars, which resulted in exploding batteries. This has put a stigma on EVs for some time, while in fact, the actual propensity and severity of such fires and explosions were far less than those of gasoline or diesel fuel cars. It is the novelty factor which puts good innovations at a disadvantage, and it takes time and lots of facts to break the barrier. Industry-wide collection of data and sharing of such data is often at odds with confidentiality, especially when innovators are risking everything to break across the proverbial chasm. The wealth of information and knowledge becomes IP, which should be protected. And this highlights a difficult balance for new technologies to maintain. A technology needs to scale for itself, but cannot do so if information about it cannot be shared. And a way to deal with that is to open the floodgates and allow a rising tide which lifts all boats. And this is exactly what we're doing in the Open Compute project. Open Compute is a cross-industry collaboration that is providing the industry with unbiased facts and often includes data to back it up. This is because all the progress in OCP is community-driven, and this is done by open sourcing any work that comes out of it. Since Open Compute is driven by hyperscale companies, it is also often more progressive than other industry platforms and focused on the front of the wave. Asperitas has proudly facilitated and guided the global immersion community to where it stands today. So I guess it's time to also explain what it is that Asperitas does exactly. We're an immersion cooling provider, and immersion cooling is literally submerging IT equipment in a dielectric fluid. Dielectric because it cannot conduct electricity. The main element which makes Asperitas unique is the fact that we can circulate dielectric fluid without any pumps. Our system does not contain any moving parts at all, and is completely passive in nature. IT equipment is immersed into the fluid with the hottest components like CPUs and GPUs, and as deep in the fluid as possible. And the heat which is provided by these chips warms up the fluid, which makes it expand and rise to the surface. And within the same dielectric bath, there are water-cooled heat exchangers, which are connected to the facility water circuit and enabling cooling of the dielectric fluid. It generates higher density fluid, which makes it sink again. This allows a natural convection circulation, which is pumpless, driven by electronics, and allows high efficiency operation without any moving parts. What also separates our propositions from the competition is a strong focus on IT platforms. The sole purpose of a technology is, after all, the protection and continuity of IT equipment. This approach is what Asperitas refers to as immersed computing, because in our technology, the focus is on the compute instead of cooling. This unique concept results in a large set of USPs for our customers. Lack of moving parts and full redundancy capabilities result in highly reliable, energy-efficient technology, able to serve even the highest requirements in the industry. Contains all functionality to facilitate integrated IT platforms, including power gearing, system management, and a whole lot more. But some of the most important features are related to the integrated focus and unique thermal capabilities, which often allow us to work with exceptionally high cooling temperatures, which allows high efficiency deployments irrespective of climate conditions. And this is also facilitated by a certification process, which enables the optimization of IT equipment to maximize the benefits of immersion cooling. We work closely with original manufacturers of equipment to evaluate feasibility and design goals. And we share our way of work and technological efforts in both directions, and often also in OCP. The optimization process is aimed at unlocking the full IT potential while ensuring the full support of original equipment manufacturers and maximizing the reliability, performance, and heat tolerance of the equipment. Some examples are shown here. These are highly resilient optimized data processing platforms which we have engineered for generic and special use cases. These platforms are designed for high cooling temperatures currently operational in 48 degrees Celsius and higher cooling supply environments. And they contain features to facilitate increased resiliency. These systems can be deployed in space-saving deployments or generic enterprise use, but it's probably best if I show some actual figures from some of these platforms, as these figures are much more relevant. With immersion cooling and particularly immersed computing, we have achieved groundbreaking performance results, which have been collected by all parties involved. Believe it or not, but this data on screen right now represents an example deployment in a small unconditioned facility, which is open to the outside air amidst India. Let me start with the PUE measurement. The design was for 1.08, actual PUE measured was 1.07, and further reduction is anticipated to 1.03. That relates to dry cooler configuration. The cooling temperature has been designed for tolerance with 45 degrees C, but the platform has been evaluated and supported for operating temperatures up to 48 degrees Celsius. While we have identified further potential to increase that temperature tolerance to 56 degrees C. And this means that this platform can run anywhere in India without compression or adiabatic cooling systems. What does it mean for a customer application? Well, that's simple. 97% of the power envelope becomes compute. You have the opportunity to focus on your core business again, which is running IT equipment instead of cooling plants. And this is the opportunity that immersion and liquid cooling brings. Thank you for your time, and I hope that I've been able to inspire you to collaborate and get a taste of a new era. For any further information, please do feel free to contact myself or Piyush from Boston, India. I hope this was insightful.
So, Rolf, thank you very much. It was an excellent presentation, I would say. You have given so much insights about liquid cooling, immersed computing, and I'm sure earlier this kind of presentation were made in very much closed room just to discuss with the design team or project team. But now we have opened up this forum to have large conversation with all the stakeholders. And we are very much sure this presentation would inspire all the stakeholders, data center owners, operators, developers, to have open discussion about application and deployment of immersion cooling in Indian data centers. So thank you very much. I'm sure there would be a set of questions which we would like to take at the end of another presentation. So thank you very much, and it is really inspiring to achieve the PUE at 1.08. And you have just mentioned like at measurement it was 1.07, and it has potential to bring down further. We are talking about 1.7 to 1.435 like that, but you have simply eliminated all these benchmark, and we are targeting like 1.03. That is fantastic. So thank you once again, and we will now invite the next presenter for this presentation.
Thank you.
So we would now invite Mr. Shailendra Bais, who is director at Pillar Power India Private Limited since 2015. He's involved in the application and market development of UPS systems for mission critical power, responsible for local operations of Pillar India. It's a subsidiary of Pillar Group GmbH from Germany. He has more than 22 years of rich experience specializing in the power quality industry. He had successfully led several good projects across the country. Some of the projects are MV UPS, the first hybrid IP bus configuration, and the first MV IP bus solutions, and many more. So over to Mr. Shailendra Bais. We are really sure your presentation would give a lot of information about how to reduce, how to eliminate the power losses in data center industry, which is very, very important. In some of the data center we have seen, they are quoting, oh, we have power losses through UPS by 4%, 5%, but when we dig out the data, it is slightly more than that. And this is the responsible area for data center industry to focus and eliminate the losses and have convert that losses in the savings. So over to you, Mr. Salander.
Hello,
So
Mr. Dhaka.
your photograph looks very dark. Maybe either you remove the background or I think this background has some problem with your laptop. You can remove this background and share your screen, no problem with that.
All right. Let me just put the screen on first.
Yeah, please.
I think this should be okay. I can't change the lighting in the room.
So you can remove the background here. You please just go to stop video. There you will find drop down options, choose virtual background. There you can remove the background. Hopefully it would be okay then.
So I'm hiding the video panel. Is that okay?
Yeah, that is also okay.
Okay, so I think good afternoon to everyone. Thank you to CII for this event. And personal thank you to Mr. Dhaka for his involvement. I think time is really short and I think I can skip the profile because Mr. Dhaka has already briefed everyone about the company. My name is Edge KPIS. I'm based out of Pillar India's Gurgaon office. And we've got a history here in India. We have been present directly through a subsidiary. Like Mr. Dhaka said, we were happy and proud to be associated with some key customers in the IT space. We started with NetApp.
Sorry, sir. Sorry to stop you. Can you please put your presentation on a full screen mode, sir?
Oops. Thank you. Is this fine now?
Absolutely fine, sir. Thank you.
Thank you. Thank you for that. Just lost that. So where was I? So I was saying that the introduction is already done. We were happy and proud to be associated with some key customers. NetApp happens to be one of them. I think they really looked at sustainability very early. We've been successfully partnered with them. We have this big site in Bangalore, which we'll talk about. Going forward, we were lucky to have Wipro. So we did the Wipro campus for Bangalore. We've done the Hyderabad campus. And off late, because of Microsoft's sustainability development budget and criteria, we were happy to partner with Microsoft. In India, we've done a pilot project for them in Bangalore and Hyderabad. That's a brief profile on the company. Getting on to the subject, of course, sustainable is a word that has been used quite a lot in the last 2 days. And in general, we'll limit the presentation to the power infrastructure or UPS per se. The presentation is broken down into 3 parts. We don't have much time. The first point is related to, of course, sustainability, decarbonize and green, limiting to the power structure. I'm not going to explain to you the ambitious targets that all these large big players have. The second portion is related to a brief review on UPS technologies. There's a lot of myth around EC and MC type of UPS. And the third part is the electrical architecture, all trying to relate and give you pointers towards sustainability and how, if you take a holistic approach on the whole infrastructure, not just focus on UPS, you have a lot of benefits. Getting on to the subject now. So we know sustainability. I just want to repeat about sustainability and what it actually means and putting it into perspective from power infrastructure. Simply put in my words, sustainability means that you don't deplete the natural resources that are available. We try to limit our usage so that our future generations are protected. Now, how does that fit into the data center footprint? Of course, it's our individual responsibility to maintain sustainability in our personal space also. From the UPS point of view, we have to look at the whole picture, not just the efficiency of the UPS. We have to look at the carbon footprint that the other components that go with this UPS or energy storage or other infrastructure contribute. So you must look at the entire picture. You have to look at the amount of bus ducts you're using. You have to look at the amount of conduits, which is PVC, that is used, the number of transformers, because you have losses and carbon footprint of all of these materials. We must also look at the recyclable and reusable part for the materials used. It is not just limited to the energy storage. There is different battery chemistries available. There's another kinetic storage available. We must also look at the UPS component. The UPS component itself has an end of life. You have a lot of electronic waste that gets generated. So look at AC capacitors, DC capacitors. So what I'm trying to say is that from the data center ecosystem, from the power quality aspect, we must look at the full picture, from the air conditioning that is utilized, the energy that is consumed, to the recyclable part. Now, coming to the complexity and components, which is the point here, what I'm trying to put here is that don't just look at the UPS TCO. You look at the overall picture, look at the bus duct, look at the configuration that you have. What you've been doing in the past might not be good for the future. And then, of course, it must be economically sustainable. It must be cost effective. So you will always have some kind of a TCO analysis, which we can help you with our technology. Now, because of the net zero carbon and sustainability drive and other such public pledges by these large players and also data center players, all the companies, they have their respective ESG, SDG, whatever you might want to call it, something related to their commitments to the environment. Now, this shift has changed the energy landscape. So it is not what was being used in the past, which was a one-way traffic. Just tap onto the local utility, put a UPS generator and feed power. There is variables that are changing, and it is changing very fast. So on the grid side, depending on the geography, you could have just a simple fossil fuel kind of energy. People are trying to tap onto renewables. You might not have on-site renewables available. You're also looking at other renewable sources to power. Now, this is just a general scenario to give you an overview that the technology that you choose today has to be compatible with various changes that are happening on the energy landscape. We call it the new power triangle. You don't want to have a stranded asset which is not flexible. The technology that we are talking about should be able to cater to the input that you get. It should be flexible in maintaining this, and it should be without any major modifications at site. So this is what we are saying in terms of looking at the power infrastructure, not just trying to tap onto renewables and saying we are sustainable. Look at the UPS infrastructure, the energy storage, it needs to do more. So when we talk about the power triangle, what we are saying is that you have terms which are you might be very familiar with. Peak shaving. Yes, peak shaving should be possible seamlessly. You should be able to change, bidirectional energy should be possible in terms of demand charge, or if you have third-party signal. Now, these are just terms that I'm trying to tell you because all is not possible in India. In India, we have some restrictions, but going forward, maybe the electricity regulation changes and we have some flexibility where stranded capacity of UPSs or gensets or gas generators will be allowed, and we can be part of the overall grid, and we will be able to use this asset. So the technology that we buy today or invest today should be flexible, and that is what Pillar is trying to say, that our technology is already there. We are already using it in other parts of the world. In terms of optimizing power usage, we are able to use with our technology either a flywheel energy storage or a battery energy storage. It's fully compatible. There is no restriction in terms of bidirectional power flow. So we are not talking about just grid parallel or grid isolated. We are able to do both grid isolated, grid parallel, and bidirectional energy flow. This is a choice that the customer has. All we are trying to say is that this is possible with the technology that we offer. And because the landscape is changing, you need to think on this ground also, not just look at UPS providing uninterrupted power in case of an outage. So the flexibility is already there in the technology that we offer. Also, if you look at the last point, this is quite important. Most of the renewables are typically connected on a high voltage or a medium voltage kind of a level. So a medium voltage UPS and energy storage that fits naturally and optimizes the whole infrastructure would make sense. I'll tell you a little bit about medium voltage because we have 3 sites already running for the IT space in India. Just to give you an overview of what the previous slide said, here this is just a simple example. We can have various configuration. What we are trying to show is there's a 3 megawatt kind of a medium voltage UPS. You have upstream standard 3 megawatt gensets. You have a grid connection coming in, and the customer. This is a standalone, of course. In a data center, you could have various kinds of redundancy. So here the customer has 3 megawatt load connected on these 3 step-down transformers, but he wants to use photovoltaic, which is say 1 megawatt. Now, with the technology that we offer, you have the flexibility that during the daytime, the 1 megawatt could be fed directly after the step-down transformer, and you could reduce the grid consumption by 1 megawatt. So typically the UPS would have some current sensing at this point. We would be able to feed 2 megawatt, which is the load on the grid, and the 1 megawatt could be used directly from the solar photovoltaic, thereby reducing your energy consumption. This is an example where we have it downstream. You could have photovoltaic and other renewables connected upstream. The behavior of the UPS is in our control. We are able to do it bidirectional. In the nighttime, in this example, you could have the 3 megawatt coming in from the grid supply. So there are various ways you can do it. This is just an example to tell you, because we have lack of time on what all possibilities are, and you should be looking at all of these angles also. Shifting to the landscape, of course, because of these commitments, we know factually that diesel is not actually very green. If you look at the NOx level, if you look at the CO2 emissions, diesel is not actually a great fit. With our technology, we can seamlessly work with diesel today. Or if you invest in natural gas engines or dual fuel engines, because you're looking at the next cycle or the next wave that is coming in, which is free hydrogen. So you could be deploying natural gas engines today. The behavior of natural gas engines is completely different to diesel. The expectations from the UPS and the energy storage dynamically changes. But as a technology provider, we are able to do seamlessly with natural gas, and then going forward, you could adopt, because of your commitments, maybe green hydrogen. So we don't want you to be stuck with standard asset because you've invested in a certain technology now and not have the compatibility when your landscape changes. And we all know that dynamics are changing very fast. So there is flexibility. We are not limiting just the box inside the building. We want you to look at the whole picture when you talk about sustainability. Just to clarify on UPS technology, there's a lot of myth about whenever the word rotary or pillar comes up. There is a reluctance from the Indian market, I would say, because generally competition or articles on the web always try to explain a technology which is on the left-hand side. This is simply put a mechanically coupled system where the energy storage is mechanically coupled to the UPS element, and then you have a standby generator directly getting coupled. This has its disadvantages. This is a mechanically coupled system on a common shaft. So the differentiation between mechanically coupled and electrically coupled is the way the energy store gets connected. Just to clarify, pillar does not fall in this category. Pillar falls in the category which is on the right. It's called an electrically coupled UPS. In the electrically coupled UPS, the UPS element gets connected to the energy storage, be it a battery, whatever type, VRLA, lithium, or kinetic energy storage. It is connected via a DC link. That means the difference mechanically coupled and electric coupled lies in the way the energy transfer happens between the energy storage and UPS. So just to clarify, we are falling on the electrically coupled, and this is what the world already knows. The conventional systems that you would have from any make with the battery energy storage or flywheel in Europe and other places is always electrically coupled. You can notice here that the standby generator need not be part of our supply. This will be a standard generator available from the customer, freely available from Caterpillar, Cummins, Perkins, Mitsubishi, whoever that vendor might be. So this was important to clarify that we fall in this category and we do not have the limitations that are normally talked about when you talk about mechanically coupled. Let's look at an overview of the three technologies that's available. To give you a brief summary, on the left, we have the mechanically coupled that I explained in the previous slide. In the center, we have the electrically coupled static type. because this is very commonly used. On the right is what we call as electrically coupled UPS, which is from pillar. The energy transfer control, like I explained, is through power electronics and DC link, and that is why we fall in the electrically coupled. So the advantages are low maintenance, longer lifetime, less discrete components. We have flexibility, however, on the energy storage. So pillar is able to deploy kinetic storage, flywheel, or batteries of any type. So we are not restricted to one kind of a product, and that is why we talk about the technologies. We have capabilities to deliver any kind of energy storage based on your needs. The flexibility lies here. So with the backup generators, we are able to connect generators upstream or downstream, and this is a direct electrical connection. This is possible. We can have systems on medium voltage, high voltage going up to 33 kV. So we can build a system on even 33 kV. We do not have any capacitors inside. This is what I meant about end of life and electronic waste. The system is quite sustainable in that aspect. We have best compatibility. The reliability figures we can talk about. I think we don't have the time, but we can give you data in terms of MTBF, comparing it with any technology and based on IEC or MIL standards. System module, here is where the difference is. We could have a single module of up to 3.2 megawatt. That means you need less components when you build larger facilities. Look, coming to the energy storage options. So just to tell you that UPS technology, it is not limited with one kind of an energy storage. Energy storage is an energy storage. There is different technologies available. We are used to batteries. We used to have tubular. We had VRLA. Now we talk about lithium ion. It could be nickel zinc. This battery is just an energy storage. It can freely be used by electrically coupled static UPSs or electrically coupled UPSs from pillar. We have full flexibility, but flywheel or kinetic energy storage system is a very common energy storage. It is a proven design. It's been in the market for a long time. We have a lot of data centers, Uptime Institute certified, that are running across the globe and here in India. So flywheel or battery, they are both energy storages. You have the flexibility to use either of them depending on your needs. I will skip these three because they are at a nascent stage. They are not commercially popular. Flywheel as a concept is not new. We know the word flywheel and we know the concept. Just to give you a brief, I think we have the business philosophy from Jeff Bezos here to tell you that flywheel is not new. This comes from, I think the book was written by Jim Collins. So the Amazon philosophy is also based on moment of inertia. Moving to a comparison, I'll spend some time here on the environmental impact, and because we talk about sustainability. Now on the left, we have composition of lead acid battery, which is plastic acid, sulfuric acid and lead. It is recyclable 99%. So you'll be surprised that you can extract lead 99% and it is recyclable. It does have toxic components. You need limited transport, but you need air conditioning at 25 degrees. It's flammable, not completely inflammable. Hardly flammable is the word that is used because depending on the need and the grid quality and the UPS element, this would change. There was a constraint on the lifetime. Today, we hear a lot about lithium ion. Personally, I do not see how lithium ions can be sustainable. I would like to get into this discussion maybe offline. When you talk about lithium ion, the recycling aspect is unclear because within the lithium ion family, you have many chemistries. Lithium ion is used for mobiles. Lithium ion is used for electric vehicles. The chemistry is different. You cannot have one recycling plant for UPS battery recycling because even in the UPS family, Vertiv offers an NMC type, Schneider offers an LMO type. There are other vendors who offer an LFP type. The composition is not really standard. So that is why recycling is not possible. There's only 2% recycling of lithium ion. Secondly, these contain highly toxic components compared to lead acid. You have still issues of thermal runaway in lithium ion batteries. You can find a lot of articles in energy storage with renewables or with UPSs where there have been instances of fire. So it's not completely safe. You have NFPA requirements in US. You have some UL requirements in US. So you are supposed to have those systems in place and differentiation and compartmentalization. In terms of being sustainable, you'd be surprised that 1 ton of lithium extraction mining requires 500,000 gallons liter of water, or 18,50,000 liters of water. 500,000 gallons of water for 1 ton of lithium extraction. So I really don't see how this is sustainable. Of course, there's a lot of marketing behind lithium ion. Personally, I do not think that I can justify the sustainability part. We must always do a cradle to grave analysis. So if you look at what is going behind the manufacturing, how much power, what kind of footprint goes into the manufacturing, and right up to the recycling, and then we can have the results. Compare this with the energy storage that we have, or what I personally feel is the right fit is the kinetic energy storage flywheel. The material is only copper and steel. And you can look at the manufacturing data in terms of what power gets consumed to produce steel or copper. It's much less. I don't have the numbers here on the screen, but I have it offline. So it's 100% recyclable. There are no toxic compounds. You don't need special approvals to transport them. There is no air conditioning requirement. We have sites in Bangalore where we've cut down on air conditioning, which is one of the USPs. They are not flammable at all, and they have a proven lifetime of 20 years. So basically, I would say that when you do select your energy storage, look at the whole picture, look at the compatibility, look at the energy landscape, look at the recycling aspect. Don't just jump onto another energy storage. There is also data available from independent agencies. I just saw them in a presentation day before yesterday, where lithium ion does not score too well in terms of sustainability. Moving on to the advantage of adopting a battery-free design. We have some sites about 7.5 megawatt. Because of lack of time, I've just put it in one picture. You have all of these batteries, whatever type of battery, occupying some space. We've been in interaction with clients. I'm taking an example of a 30 megawatt data center. A 6+1 is a standard building site. We made a calculation based on the layout that was planned with lithium ion and LMC type, LMO type battery. And we are able to knock off at least 30,000 square feet of white space within the entire building, which would mean for a co-location provider about 1,000 racks, which is a huge kind of a saving, both in terms of revenue or in terms of construction costs. So if you have a tier 3 data center, average cost is whatever, 40,000 rupees. If you have a tier 4, it's much higher. So it's a benefit that is really cannot be ignored. All this free space can be eliminated if you have a kinetic energy storage solution. We have sites which I will try to show you in terms of benefits, but this is really something that the hyperscalers or the large colo providers must look at, and this is something that cannot be ignored, is my opinion. Looking at the product, one slide. So what we are offering is an electrically coupled system. We have the options of using any kind of battery or flywheel. We have a natural sine wave generation. Like I said, no discrete component, so the MTBF is much higher. There's no power capacitors, electric fans, which result in higher MTBF because of lower component count. There is a wide flexibility between the external diesel genset and UPS arrangement. I wanted to put one slide on the USPs of our product. Moving on. The second interesting part, I would like you to pay attention to this, please. There are a lot of consultants from Europe and US who are working with hyperscalers and data center operators. And this is a quote from HPF, Robert Thorogood, talking about the benefits of going at a higher voltage and not looking at a standard solution. Basically, when you started data centers in India, it was 3 megawatt, 5 megawatt. What we are trying to say is that when you scale up to 20 megawatt, 30 megawatt, the configuration, the design that you use for 5 megawatt will not be feasible. You have other challenges. You have to be prepared for the next wave. We all know that artificial intelligence, machine learning, deep learning, virtual reality is driving the power demand. The rack power densities are going up from 3 to 10 kilowatt, and it is likely to touch 20 kilowatt. So you have to look at flexibility in terms of your infrastructure that you plan today. Excuse me. Excuse me. So there is a limitation on low voltage. You can't go beyond 6,000 amps. We are talking about taking it to the next level. Like I said earlier, renewables are also connected on medium voltage, and the system becomes overall much more efficient and sustainable. I'll tell you briefly how. So this is just a summary from a US client that was readily available. This is talking about a 10 MVA distribution. The voltage is 480 volts. It would change, but overall effect would be same. If you change to India, 450 volts. The comparison is 13.2 kV versus 480 for India. It could be 11 and 415. If you have a standard LV UPS, you have a step down. You step down the voltage 415 feet to the UPS. Depending on the distance, you have a lot of cables, and you have losses on the cable. So there's first the loss of the step down transformer, the loss of the UPS. We're talking about modular UPSs here. So you're talking about 96% efficiency. There is a loss on the cable. So your total loss is 6.4. If you have a 30 megawatt site and you want to save space and you want to take it on medium voltage, you could do that even with low voltage. So you would have the same loss, 1.2 for the step down. The UPS loss remains same. You can step it up, put another transformer, add some loss. You can see the loss on the medium voltage cable. So 0.1, and then you again step it down for the data center. Your loss would be 7.4. What we are saying is you could simply put a medium voltage configuration. This is the loss from our UPV system. We're talking about online, not eco mode, energy management, whatever you want to call it. It's up to 97.4% kind of efficiency, 98% efficiency, depending on the block size. You can power the facility directly on a medium voltage, just step it down inside the building, and you can eliminate a huge amount of loss. Of course, the configuration of the UPS also matters, but in concept, medium voltage is much more efficient and is more sustainable. Why? If you look at feeders, so you see this is a medium voltage feeder. You are using a lot of copper, a lot of PVC, and that is what sustainability means, using minimal and not putting a stress on your resources. All this 5,000 amps can be done in 500 amps if you go on a medium voltage, so you are using less steel. If you talk about transformers, you can look at 6 numbers of transformers here. You have losses here on transformers. This can all be consolidated if you use, I have a further breakdown, but in this presentation, we are limiting to the concept. If you move it on a medium voltage, you have possibilities of transformer consolidation and reducing your overall losses. This comparison is, of course, for a 35 kV and a 4.1 from a customer in US, but we have done this analysis for customers in India. Now, if you do this, you're also reducing plant room space. So you're actually contributing in terms of your sustainability objectives, not only doing the same thing on a 30 megawatt or a 20 megawatt level. Mutual heating, of course, there are other factors that you can look at. So when you do cable grouping, consultants are aware of this. There is mutual heating and higher losses. All of this can get eliminated if you go on a medium voltage level. And like I said, the added advantage is that if your power demand suddenly goes up, it's much simpler to increase capacity on medium voltage. We can build up to 50 megawatt on a standard medium voltage solution. We have sites globally that are running on this concept. Sustainable construction. So you don't want what was happening under the floor, many years ago. You don't want this kind of a mess. You want to eliminate the number of components, the amount of copper, PVC. So please look at the overall picture. Don't just look at the UPS efficiency. Look at what the air conditioning consumes. Look at what the construction cost is. Look at the bus ducts. Look at the transformer losses. And you will see there are a lot of benefits of going on a medium voltage. So key takeaway, don't look at just the UPS box. Look at the whole picture. Don't look at just one type of an energy storage, because this is what we know about. In terms of working sites, very quickly, I can show you an overview of the NetApp site. This is the NetApp facility at Bangalore. The main building is 1 million square feet located here. The space allocated for UPS element DG was about 400 meters away. This is a hybrid system where the UPS is on 11 kV and the paralleling is done after the step down, and it is in an IP bus configuration, which has its own advantages. You have up to tier 4 certification already available for a constructed facility. We have customers who have this configuration with tier 4, but the UPS remains N+1. There is no space consumed inside the building. We have eliminated almost 150 tons of air conditioning we were able to save almost 7,000 to 8,000 square feet for us for NetApp. Now, NetApp is not a colo provider. When we do the comparison for a complete data center, 20 megawatt, you will see tremendous savings. But this has already been running. We are very thankful to NetApp for giving us this opportunity. I think the whole management and the whole team was in sync in terms of sustainability, and they've done wonderful things, not only on the power infrastructure, but overall as a showcase. This was the first site we did. Google picture, this is where we are on a medium voltage, 7.2 megawatt. The connected load is much lesser, but this was what was planned. We are 400 meters away, and then power goes on a medium voltage inside this building. So UPS on medium voltage, you can eliminate all the space inside and all the air conditioning. This is the second site, which we have commissioned last year. This is the Wipro campus. Two buildings are, one building is data center, rest is normal software, IT usage. And the same thing has been done here. The configuration again is on medium voltage. We have a separate UPS and a separate genset. So there are advantages there because of sustainability. These are the customers who've already done it. We've done it for them in Hyderabad now. And I think I am good on time. I'm at the last slide. So conclusion, sustainability, please don't look at just the boxes, look at the whole picture. We should not be robbing Peter to pay Tom. We should not be, trying to use natural resources in one place and trying to say that we are sustainable on the other side. I think that is what I can briefly say. Please visit our booth if you would like to connect with us offline, and we can have a one-to-one discussion. We have a virtual booth here. Thank you, CII, for your time. Am I good on time?
So thank you.
I think I took it.
And I think it was a good presentation showcasing different concepts, technologies, which are used in power solution especially for data centers. And this is a big area to have very much specialized focus, because this accounts a lot of losses. And if you don't implement the right deployment, it will create problem for many more years. And there would be losses which would not be retrofitted immediately after the commissioning of the data centers. You also mentioned about lot many integrations of UPS and energy storage with the solutions that would be having some harmonization with the renewable energy, and that is the future goal for every data center. They are trying to have more and more green power. In fact, some of the data centers they have already announced like by 80 to 85% of the power would be coming from the renewable. So it makes sense for every data center to adopt this kind of technological solutions. Lastly, the recycling of different type of energy storage or battery system. I think this needs more and more physical discussion. At this moment, it would be difficult to have discussion one-to-one, but yes, it needs a physical interaction. So once the lockdown over, we will conduct some workshops so that we can have a further deliberation on that. We have received some questions, but we have very limited time. The first question is to you, Mr. Salender, is have you done any implementation in India with regard to low voltage and medium voltage UPS?
Yes, I think I tried to cover that. We have low voltage solutions, and we have hybrid solution and medium voltage. I did mention we have GE is on low voltage. I have in IT space, NetApp, Wipro Hyderabad, they are all on medium voltage. Microsoft, we've done a complete unique solution. It's a retrofit of the existing systems. We've eliminated the air conditioning, moved them outside. So that is on low voltage. So it's possible to do. So we have the full portfolio. We can do whatever configuration is required, and based on the needs and what would be the right fit.
Right. So just a follow-up question. So could you please quantify how much saving you have achieved with this implementation in real time, having bigger or large size data centers?
So I think the problem was that I think for NetApp, the load is not as high as was expected because I think some of the servers were moved to another place. The planning was to have 3+1. I think currently the load is not even for I have to check, I think for 1 unit. So the efficiencies would not be as high because of course this system is optimized for 40% to 100%. So yes, you should be able to plan and design the solution in such a way that you have an optimum loading. The technology is optimized for 40% up to 100% efficiencies. We have other sites across the globe where efficiency numbers are higher. I don't want to get into a debate of a 95 or a 96, 97. Conceptually, what I'm trying to say is that if you look at a box to box efficiency, we might be almost the same. But when you look at the air conditioning, when you look at the other infrastructure, the losses, like I explained, on the transformer, on the bus duct, you will have an efficiency higher by 2 to 3%. We've done it. We were part of the Microsoft discussion in India, and they looked at real-time figures for conventional battery-based system with the same loading, and they were able to see that yes, there is an efficiency saving, there is an air conditioning reduction. I think air conditioning is the major factor, and also the whole infrastructure. We would be, I would say, 2% to 3% higher on a similar load level overall.
Okay, so thank you very much, Mr. Salantar. We had wonderful session. First presentation was on immersion cooling that has huge potential in India, especially for all the colo data centers as well as the enterprise, start from medium to large or hyperscale data centers. Then your presentation was clearly mentioning the power losses and how to overcome with this kind of challenges. So definitely there would be much more debates. We would try to schedule in couple of months once this lockdown is over. And we thank you for your presentation and for having you for this very important session today. So thank you all the attendees.
Thank you so much. I hope there are some takeaways. Thank you so much.
Yeah.
Muting now.
So we are having another session at 3:30 and try to visit exhibition stalls. There are companies and you will find it very interesting because first time we have put this kind of virtual store there. Thank you very much. I look forward to you to the another session.